Dear friends, welcome again. Let us discuss about the bending moment diagram will either be concave or convex in case of parabola. So many students got confusion. Like suppose we have example a beam, the cantilever beam. Example cantilever beam, cantilever beam with UDL over the entire entire length. Okay, so what we have to do, our task is to draw SFD and BMD, means shear force diagram and the bending moment diagram. So this is our beam fixed at one end and free at the other end, and this I'm giving name A, this I'm giving name B, and UDL, load is UDL, and the intensity W kilonewton per meter. And this intensity also can be shown like that. Already we have, however, already we have discussed like, and the width arrow here, which will which shows the direction of load. Okay, so this is equal to this is same way. Okay, now our task is what? To draw FBD first. So what will be? This is our end A, this is our end B. So this load will be what? And the length is what? Length is L. Okay, and support reactions we have to show. This is V A and it is M A, and this will be then W multiplied by L. But for this we have to take we have to cut the section. So suppose we are cutting this beam from here, and the name I am giving like one section, means one section. This is the cut section. Okay, so for this I am not going to detail about how the SFD and the BMD will be. Directly I am writing so that the main purpose can be fulfilled. So what about SFD? So SFD here, it becomes here, 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 and this is our obviously A, B, and this is the magnitude L, and this is positive shear. Okay, so it is obviously this is the variation is linear variation. Okay, and if the shear force variation is linear, then what about the bending moment diagram? Shear force, तो bending moment diagram में क्या हो जाएगा? Because shear force is multiplied by the perpendicular distance. Okay, the distance multiplied by distance, and suppose shear force we are cutting section, and from here it is x distance. From here means from B to section 1 1 it is x distance. So what will be our SF value? Then SF value means it will be Wx, and it will be multiplied by x. Either we take the moment, let us cut the section from B, this is and this is, and this is what, this is our Wx, and this is suppose S is shear. This SF here we have denoted as shear force, and this is the direction of moment we are assuming. Okay, so that's why suppose we take moment about B, so it becomes like or we take moment from we are taking moment, summation of moment about B, then 0, and the sign convention, this we are taking minus, means clockwise minus. Okay, and this distance is what? It is x from B. So what will be, and this section is, this is section 1 1, so from here to Wx, and Wx will be what? It acts at the mid, so that's why it will be from here to here, it is x by 2. So satisfying this criteria, and then the moment here direction is what? The clockwise, that's why minus m, and this is the moment about 1 1, and also the moment means it will try to, Wx will try to rotate the beam the clockwise, that's why Wx multiplied by the perpendicular distance, this is, and this is equal to what? M minus Wx square by 2. Okay, so this I was going to explain here. So WSF what we are getting here. So what we are getting SF, we are getting Wx, and it is multiplied by x in general case. Okay, so what happened? It becomes Wx square, means if the SF is linear, then the bending moment will be parabolic. Okay, and now let us come to this beam, specific to this beam. For this, what about the moment? Okay, so this is the moment for the right side, this beam right side. What we did here, we cut the section, and this portion we have taken into consideration for our study. Why not this one? Because there are three reactions in which horizontal reaction is 0, so 2 reactions are there, so इसमें ज़्यादा टाइम लगेगा, ज़्यादा कैलकुलेशंस लगेगा, ठीक है। और यहाँ पे क्या है, फ्री एंड है, कोई रिएक्शन नहीं है, ठीक है। so that's why we are choosing the right side portion. Okay, so what will be now? So this is the beam from here A to B, and this portion we had taken 1 1 1 1 here, Wx. Okay, and from here to here it is x. Okay, so what about the shear force diagram and the bending moment diagram? So shear force diagram, what we get from here, if you see this figure, so shear force is what? shear force. So what we have to do, Fy is equal to 0, then S in positive direction, but it is as per the sign convention. We have to follow the sign convention. As per that, what is, I'm going to write here like this is, and this we take a positive, we take negative, this we take negative, this we take positive. So as per this, what we get, we get uh, and this is the which side, right side, this is which side, left side. Okay, so coming to this, we are going to satisfy this, then as see uh, the direction, so direction is like this, that's why minus s. But what about wx, that is opposite to that, okay, means this one, so plus wx is equal to 0, means s, and s is what, shear force, s is equal to wx. Okay, and the shear s is equal to wx, and this is what, the shear force. Okay, so just below this, just below this we have to, however this we can move, so just below आपको, however I am not doing here, लेकिन आपको जस्ट आपका लोड डायग्राम जो बीम के जस्ट नीचे आपको ऐसे भी ड्रॉ करना है. ओके, एंड दिस आई एम सपोज. Okay, and how it is varies, s is equal to wx, and x is varying with the distance, and x is equal to this is working, if x is equal to 0, then we're talking about 8b. If x is equal to what, means L by 2. Then x is equal to L we can take, suppose x is equal to L, then S becomes WL. Okay, and it is 8A, it is 8A. Okay, so as per this, what will be, at B it is 0 value, at A it is WL. Okay, and WL is positive, so that's why with this magnitude we are taking, and this, now what you have to do, it is linear, it is varying linearly, so just आपको मैच कर देना है इसको. Sorry, I am not able to do it properly. ये आपको, yeah, this is your linear variation. Okay, and what about, we have m and it is with minus, so just below we have to draw the BMD. This is what, this is the accept, so just below here, and this is A, this is B of length L, and its intensity here, it is WL. A, and it is B of length L. Now what will be, and what we have, M is equal to, we have, you can see here, minus WX square by 2, and X we are measuring from B, X we are measuring X from B, okay. So what will be, if suppose X is equal to, now we are applying the boundary conditions, X is equal to 0, means we are talking about at B, then MB will be 0, and X is equal to, suppose x is equal to L, means we are talking about 8a. So what will be MA? MA becomes minus WL square 2. Okay, with applying the boundary condition, and so here it is 0, and at MA it is negative value. So suppose it is coming somewhere here, so it, ये तो ऑब्वियस है कि यहाँ से एक लाइन खींच दी हमने ये. Now it will be, the question is like this way or it is a parabolic, parabolic, and this is also parabolic. Okay, now question is which one is correct? Either this one is correct or this one is correct. So we have one tricks. So what tricks we have? One tricks, or you can say tips we have. And what is this? So suppose this is x, y, and this one, and it is positive and constant, and constant. ठीक है, पॉजिटिव है और कांस्टेंट है, मीन्स सपोज शेयर फोर्स कांस्टेंट है, ठीक है, एंड पॉजिटिव है. So this we follow, and what about coming to this? Same here, y, x, and positive, and magnitude is, what is magnitude? Magnitude is decreasing. So this kind of curve. Y, and it is x, and magnitude of what? This moment, magnitude of what? The shear force. ठीक है, so the value is positive, suppose, means moment value is positive, and magnitude is increasing. Then this one, similarly, x, y, and this one, if magnitude is negative and constant, and constant. X, y, and magnitude is negative, and it is decreasing. Then this one. Okay, here magnitude is, it is x, y, x, y, and magnitude is negative, and it is increasing. Then we opt this one. Okay, so what we have, the moment equation. The moment equation we have m is equal to we have minus w x square 2, and beam we are considering from A and B. Here wx, here the shear, and this is the moment. and this distance is what? This is x from B, and from here it is x by 2. From here means here is what? Actually there is a section 1 1. Okay, so you can see here, अगर B से देखें, सो B से देखें एंड B से A की ओर चले, सो हमारा निगेटिव तो है. व्हाट अबाउट मैग्नीट्यूड? द मैग्नीट्यूड इज either increasing or decreasing. So magnitude is increasing. Okay, so it is minus and magnitude is increasing. ठीक है, कैसे चेक करेंगे? सपोज x इज इक्वल टू पुट सम वैल्यू लाइक 1 2 3. ठीक है, सो मैग्नीट्यूड ऑब्वियसली इंक्रीज होगा. ओके, सो व्हाट अबाउट द BMD? ठीक है, अब BMD में क्या है? ये आपका B है, ये आपका A है, एंड बाउंड्री कंडीशंस से क्या पता चला हमें? एम बी इज इक्वल टू 0 एंड एम ए इज इक्वल टू माइनस डब्ल्यू एल स्क्वायर बाय 2. ओके, सो इट इज़ वेरी ऑब्वियस. ये कैसा बनेगा? ये माइनस क्यों जाएगा? कहाँ से स्टार्ट होगा? बी से स्टार्ट होगा. अब देखते हैं, अगर मैग्नीट्यूड डिक्रीज हो रहा है, सो कैन वी सेलेक्ट दिस वन? आप देख सकते हैं कैसा है ये. ठीक है, अब इसको इट इज जस्ट लाइक दिस वन. ठीक है, मतलब आप देख सकते हैं दिस पोर्शन इज विद मीन्स concave or convex we have to take. So this will be, आप देख सकते हैं, it will follow this criteria. So that's why from B to A हम क्या करेंगे? Like this one, and it is minus and it is parabolic. Okay, parabolic, and whether it is a concave or convex, so it is concave. So what we come to know from this lecture, we come to know how to draw the SFD and the BMD of cantilever beam with UDL over the length, and by solving that we came to know like it is the beam is loaded with the UDL. then SFD क्या होगा? UDL है तो obviously SFD कैसे बनेगा? ट्राइंगल बनेगा, क्योंकि हमें वेरिएशन, linear variation we are getting, linear variation we are getting. ओके, अब SFD अगर लीनियर है, ओके, शेयर फोर्स लीनियर है, मीन्स डब्ल्यू एक्स, सपोज डब्ल्यू एल, एंड मोमेंट निकालेंगे, सो ऑब्वियसली परपेंडिकुलर डिस्टेंस से मल्टीप्लाई करना पड़ेगा. सो क्या हो जाएगा आपका जो एम एक्स था या एम एल, वो एम एक्स स्क्वायर हो जाएगा और एम एल स्क्वायर हो जाएगा, मीन्स द पैराबोलिक. ओके, एंड वेदर वी आर गेटिंग फ्रॉम द कैलकुलेशन by solving it, whether you're getting positive या नेगेटिव वैल्यू. ठीक है, नेगेटिव वैल्यू हो रहा है, उसके बाद दिस मोमेंट इज वेदर इंक्रीजिंग और डिक्रीजिंग. ठीक है, तो उसके लिए एक बेस्ड ऑन द, वी कैन से स्टडी, बेस्ड ऑन द ऑब्जर्वेशन, वी हैव मीन्स हैव कंक्लूजन और यू कैन से टिप्स. ठीक है, बहुत सारे स्टूडेंट्स कंफ्यूज होते हैं कि कैसा कब कैसा बनेगा, कब लाइक ऐसा बनेगा या ऐसा बनेगा. ठीक है, तो इसीलिए दे आर विद दिस एग्जाम्पल, दिस यू कैन टेक and take the benefit. ठीक है, so based on this, like we have 1 2 3 4 5 and 6 conditions, and conditions क्या बोल रहा है कि either shear force constant है, वेरी कर रहा है, पॉजिटिव है, नेगेटिव है, मैग्नीट्यूड डिक्रीज हो रहा है, इंक्रीज हो रहा है, बेस्ड ऑन दैट. सो दिस इज आवर bending moment diagram. So what was our title? Our title was bending moment diagram, either concave or convex. Okay, so this is determined by either the positive value, positive or negative, and or magnitude is increasing or decreasing. So here shear force SFD में तो कुछ प्रॉब्लम नहीं था, ठीक है. SFD was पॉजिटिव एंड द मैग्नीट्यूड वाज, अगर देखें, अगर बी से देखें तो इट वाज इंक्रीजिंग. लेट अस सी, अगर ये देखते हैं पॉजिटिव एंड डिक्रीजिंग, बी से पॉजिटिव एंड डिक्रीजिंग, तो आप देख सकते हैं पॉजिटिव एंड डिक्रीजिंग. और तो कौन सा क्राइटेरिया यूज होगा? ये तो नहीं होगा, सेकेंड, थर्ड, फिफ्थ, सिक्स नहीं होगा, बिकॉज इट इज नॉट पैराबोलिक, नॉट क्यूबिक, एक लीनियर इक्वेशन है. ओके, और हमारा कैसा बना था? दिस वाज आवर SFD ए बी, और हम बी से देख रहे हैं तो क्या हो रहा है? बी से इट इज पॉजिटिव एंड मैग्नीट्यूड वाज इंक्रीजिंग. ठीक है, सो पॉजिटिव, दिस वन पॉजिटिव, बट इट इज कांस्टेंट या, बट इट इज़ वेरी ऑब्वियस. ठीक है, ये तो सिंपल एक लाइन इक्वेशन है. तो एक लाइन बनेगा और यहाँ पे जीरो वैल्यू है, जीरो, यहाँ पे सम वैल्यू है लाइक WL. तो दोनों को आपको जस्ट आपको एक लाइन ड्रॉ कर देना है. तो SFD में तो बिल्कुल भी प्रॉब्लम नहीं है. जो भी प्रॉब्लम था BMD में था. ठीक है, सो BMD में what we came to know, this sixth one, the tips number 6 is valid for our this beam, means cantilever beam with the UDL over the length. Thank you.